So I'm Deepan Patel from Phoenix Contact. I'm the industry manager, so I've been with Phoenix Contact for about 5.5 years. And I'm just going to take you through my PowerPoint, but basically it's going to be talking about the introduction of the presentation, who needs controls within data centers, so and the importance of that for data centers in the market, who are Phoenix Contact, and then obviously talk to you a bit more about our scalable and integrated solutions as well. So just that. So yeah, basically, I think Alex this sort of morning he was had some in his presentation was talking about the sort of market research and that. So I've just got a bit more information on that. But yeah, the data center market is invested in 2022 $1.6 billion dollars since 2022, and it's also further expected to reach about 1.8 by 2028. So you can see that the actual growth and its expansion of data centers in a market as an industry is growing at an exponential rate. The revenue of that data center market as well is also projected to reach about 268. I think that was figures for the UK, 268 billion in 2023. So you can just see just the amount of investment and revenue that's going into the market. There's an ever more increase in demand for data storage, the processing. One of the speakers just previously was talking about AI and its emergence. I think that is equally going to grow our demand and the requirements for our data centers to handle that as AI is growing in itself as well. And obviously that processing data. So the more processing data we require, the more of the demand that we put on our data centers. And of course, with everything, it has to be managed as well. So there's an increased demand for that. So of course, in today's world, sustainability is just so important in any kind of aspect now, I think. And energy, from what we've seen in the past couple of years just showed that. So being able to be sustainable, and in the topic of data centers, again, that is also a growing importance for the industry. And within data centers, the building management systems that actually maintain the efficiency of these data centers. So there's a lot of systems that actually play a vital part in making the data center sustainable. So some of those discussions that we just had before was about the systems. Within that system, obviously, there's a building management system within it. So being able to maintain it at a high efficiency rate with the operations in data centers is equally important as well. So yeah, the trending topics of data centers is sustainability, but also from a controls perspective as well as system availability as well. So these are very trending topics. It's a growing topic as well, of course, of importance. So Phoenix Contact, actually one of our kind of corporate goals is to become an all-electric kind of society, part of the ethos as a global image. And as part of that all-electric society is looking at ways to become sustainable. So we ourselves within our own manufacturing facilities are looking at ways of improving our sustainability in terms of productions, in terms of packaging, and also making sure that the actual solutions that we provide to the market, we also reinvest in and build that within our own manufacturing centers as well. So with data centers, I don't see that any different. So with sustainability, is looking at things like reusable water and things like that to actually provide more sustainable ways in terms of efficiency, and then obviously system availability for the data centers. But yeah, equally the importance of control is growing. So a few PowerPoints earlier was talking about sort of server racks and that. So yeah, within a data center market, it comprises of all hardware related expenses used for setting up and maintaining. So there's three basically cover subsections of that. So then you've got the servers, you've got the storage, but then equally you've also got the network infrastructure. Nowadays, what IT companies are now actually doing within data centers is they're looking at more the sense of external providers to manage their operational aspects of the IT infrastructure. So that's by what we were talking about earlier, so things like co-location, but there's also this growing stage of hyperscale data centers and that as well. So that's where data center operators are leasing out capacity within their data centers for the IT organizations and IT infrastructure. What we're seeing with the growth of the figures as well is obviously that importance of the controls for the data centers and the impact that the controls has on the efficiency and of course the availability of that data center. So when we talk about availability of data center, it's not just the entirety of its own, it's actually looking at, for example, the data hall as well within that data center. So of course the importance of control and what it does for the data center is reliability and availability. It's looking at mitigating risks and enhancing security. So things like risks associated with cyber attacks, that equally is important for our data centers, but also enhancing security and site security for the data center as well. As I think just in the previous speaker session, we was talking about regulation as well with temperatures. I think that's important. So compliance, as this growth of industry develops further, I think we're no doubt going to be seeing more kind of directive legislative regulations and standards that are coming out soon as well. So the compliance of industry regulations and standards. Of course, within the data center operators, there are contractual agreements as well that are initiated both with the data center operator and the actual, the end user effectively. So, whether if it's Amazon, Google, there's an actual contractual agreement. So that is looking at things like being able to be under a certain temperature range within that data hall and the cost implications of if that is not met. So the importance of the controls system is exactly making sure that they are within their contractual agreements. And then obviously looking at renewables energy is equally important. So within a lot of data center builds and that, they're looking at, whether if there's a solar farm nearby. Earlier on, I think it was Alex from Vertiv that was talking about the importance of the Park Royal data center. So equally, they're looking at district heating as well. So there's new ways to kind of all this kind of sustainable ways to look at the energy that's created from the data center and the heat that created from their ways to perhaps use that in heating an office building, or for example, as was mentioned, like a residential a building nearby, to basically look at the district heating systems and that. So equally, it's also important for that as well. So the reliability and availability, just sort of drilling down on that a bit more. So basically what we're talking about is reducing the downtime. So when a data center or a data hall, for example, something might happen, they might have one of the digital cards that have sort of gone down, or system has gone down, for example, they're looking at trying to bring that back up. So obviously it's important as part of controls to make sure that that is minimized as possible to reduce the downtime for that data hall, for example. Obviously, with the reliability and availability is making sure that there is a part that is replaceable on site, for example, or there's one accessible very close by. There's obviously financial losses that could be occurred for the data center operator. What's also important is commonality of vendor parts. So parts obviously of different vendors and different types of solutions can cause obviously having multiple kind of parts in the stores as well. So it's important to have a more common platform for parts of vendors as well. And then again, mitigating those risks and enhancing security. So that's talking things like the cyber security for networks. Some of the data centers that we've worked on in the past, obviously they're government related. So it's important for them to know what type of cyber security threats that are coming out in today's world. So making sure that the actual networks are resilient and robust, so that they actually protect their IT infrastructure. Access for the security, so that's looking at enhancing CCTV, face recognition, and things like that as well. As those sorts of solutions develop, it's important to make sure that you have multiple contractors and that coming and going on site to make sure that the access security audit tree as well. So looking at, if there's an engineer that was doing work on a site, for example, what kind of work was done, so making sure that it's followed to the T. And of course, there's complex networks that are going on. So, within the data center in itself, being able to ensure the security within the complex network, so that if the network system goes down, they can actually look at other ways to reroute network infrastructure within the controls or within the building management system as well. And yeah, obviously, as I said earlier about the contractual agreements, the operational contractual agreements, making sure that the temperature. I mean, I recently visited one, and they were talking about quite a few tens of thousands of pounds that they can get in if they are outside of contractual agreements. So it's such an important part of the controls that plays an important part on making sure and monitoring the temperature, and also in controlling, so that if, say, something does occur, they can react to it a lot more quicker as well. And then obviously sustainability. So one of the ways that a data center recently looks at is reusing rainwater. So it basically rains a lot in the UK. So we're quite fortunate that we have a lot of rainwater that can be collected and then harnessed to cool the data centers down as well. So that's another way that this particular data center looks at basically reusing, and again, that improves their sustainability and also PUE rating for their data center as well. So a bit more about Phoenix Contact. We're basically one of the world market leaders in industrial connection and control technology, so automation. We're actually a privately held or family-owned business, and have been since 1923. So that puts us in quite a vertically integrated market, but also means that we can be financially independent and growing our solutions. And it allows us to be more flexible in terms of reinvesting and generating that revenue to put back into investments of our solutions. And one of the ethos is obviously becoming a company that is what we're calling an all-electric society, so becoming more sustainable ways of our own ethos in terms of production and manufacturing. But these are the sorts of markets that we operate in, and obviously infrastructure's where I sit in within the market. So we look at building technology, and obviously within that is data centers as well. So with our kind of great combining solutions, what we have is a controller that is a building management controller. It's a controller that's actually sit on the Niagara framework. So for those that might not be aware of what Niagara is actually a software platform that is looking at integrating many subsystems or protocols of a building system and integrating that onto one single software platform. So it's a platform that is basically owned and run by Tridium, or Honeywell, if you want to call them, but basically that allows multiple subsystems or multiple protocols to talk onto one single software platform, which is quite intuitive. And then we have, so that's the software element, and then what Phoenix Contact have is the hardware solution, so which is known as the ILC 2050 BI, or Building Intelligence Controller. And you can see some of this picture here that's also on the screen here that shows you the 4 Ethernet ports as well. I'll talk to you a bit more about some of the advantages that this controller can provide. So it's modular. So again, a lot of what I saw from the previous speakers is modularity and the growth of that for data centers. What's good with the ILC controller is it actually complements what data center operators want to see, which is modularity and being able to build in more chunk blocks kind of design. So what the controller supports is up to 63 IO modules per controller. So what that offers to the operator or to the system integrator is being able to design a high IO compact application. So it's not really a module, it's not really points, it's 63 IO modules. So put it into perspective, we have one digital input card that can support up to 32 input points. So if you times that by 63, you can see just how high the count can go. what that does with it being more modular is that obviously it's more scalable in its design as well. Because it's compact, the actual controller is only 80 millimeters in terms of footprint. So a lot of the kind of building controls that get used in data centers, you tend to have a lot of, big control panels and that. So obviously this is a much more compact footprint. So that's also quite key as well within the building automation market. And the flexibility of the hardware. So we offer some seamless integration. So things like with the other protocols. So MBus is for a particular protocol used for energy metering. DALI, so for lighting. So these are things and these are ways that the data center operators can look at ways to become a bit more energy efficient in terms of their lighting solution. So DALI is a lighting protocol, and then obviously BACnet, which is the standard building protocol that gets used. It's a high quality. So what we've basically done is, as I said earlier, Phoenix Contact, an industrial manufacturer of control technology, we've taken what people might perceive as PLC, so it's a programmable logic controller. And what we've done is a lot of the benefits from the industrial PLC market and brought that over to the building automation market. So what we are seeing is, as this has been around for several years now, is we're seeing the importance of this for a lot of data center customers that we work with now to actually realize and benefit that a lot of what they're doing in terms of their builds and designs, it basically suits with the ILC 2050 controller because it's robust. It's a high industrial grade kind of product and a platform for them to use as well. These are just listing some of the typical integrated I/O options. So we do analog inputs, outputs, digital, and relay, temperature sensors. So MBus for energy metering, as I said earlier. So further Modbus modules, so 485, DALI in an ocean for the lighting. So you can see the flexibility of the hardware is quite important as well, because with other vendors there might be a particular protocol that you want to talk to or particular requirement that you might have, and the module that the vendor has, for example, might not support it. So it's being able to look at the flexibility of all of these modules that we provide. So as I said earlier, because it's an industrial grade product, a lot of the benefits of the industrial market, things like the shield connection for DIN-rail to minimize noise, for example. There's isolated terminals. So you've got the isolated terminals for further noise reduction. A lot of the controls, and you can see the channels on these output modules, is spring cage. So from an engineering perspective, the rollout of these controls is much more quick and efficient as well. So even simply by changing a module, for example, you can just actually take the header off. So the top header comes off the block, and it allows you to then slide out the module and then reinsert a replacement module, for example. There's also the bus protection that's available to isolate different voltage circuits within your design. So you can see the entire flexibility of the hardware with the complement of the software that Niagara provides is really quite cool. We also have a central I/O solution. So this is a range of I/O modules that are connected on an ILC controller. But equally, in terms of designs, we also have remote I/O solutions as well. So some of the advantages that this provides is being able to collect and control I/O signals with a distributed approach. But we also take Niagara here, and we've developed a driver that's specific for Niagara that allows you to easily discover your remote I/O. So any modules that are connected on your remote bus, being able to actually scan that on the bus, and actually it responds by, I've got this many modules, and then it automatically creates your I/O points in terms of your design. So then when an engineer goes to program the points, he's already got access to it. So which is really quite powerful, because with Modbus, it's anyone that's played with Modbus is quite traditional that you have to go through the Modbus tables and things like that, whereas this is what we've done within Phoenix Contact to enable that and reduce the engineering time. So you've kind of shaved a couple of hours just by this type of driver that offers the quicker commissioning times. And the Niagara ecosystem, just to talk to you a bit more about what Niagara can do. Basically, as I said earlier, it's a software platform, but a lot of the protocols, so KNX, LonWorks, for example, MBus, as I mentioned earlier. So it's a software platform. Basically, all that you have to do is license the software with number of points that you need. But yeah, you can obviously kind of get that through us. But it allows you to be able to integrate on that one single kind of platform. So it's quite powerful for that. There's a bit of a case study I'd like to kind of show you in terms of an actual customer and some of the pains that they were facing. So some of these pains they were facing was exactly what I mentioned earlier, downtime and availability. So panel sizes were getting bigger because you can imagine just monitoring UPS statuses and battery statuses. You're talking a lot of digital statuses, temperature. So for analog, the panel size was increasing for this particular customer, and they wanted to look at ways to reduce that. The integration of multiple gateways. So one of the key things I briefly talked about earlier was the 4 Ethernet ports that the ILC controller supports. That has 2 network interface cards. So that allows a data center operator, let's say, for example, to have on 2 network channels or 2 network routes to be able to in their network design. So things like Ethernet switches for IP routes, it minimizes that because the ILC supports that, because it's also got 4 Ethernet ports as well. So things like IP static routes. The communication over different protocols for this customer was also not harmonious. So they wanted to be able to look at a single platform to be able to bring in those different protocols from other different vendors as well. So it might be different HVAC vendors, for example, being able to interface from that. So yeah, multiple vendor products. Again, there was no common part from a building control perspective. So they wanted to look at being able to find ways where if there is a card that needs to be replaced or if there is a downtime, how quick can they turn that around and bring that system back up for the customer. So again, that was some of the pains that they were facing. And then obviously the ILC came on site for them, and they sort of almost immediately saw some of the key benefits for this data center. So obviously Niagara was used to monitor and control the bespoke cooling systems. So again, earlier I mentioned about using rainwater. That's exactly what the customer does. So it collects rainwater and puts it through air coolers and basically mixes the two to bring the temperature down within the cooling, so within the data center. So it's things that basically to become more sustainable. So it was quite a focusing point for this data center customer. Obviously, the data center, a hyperscale data center, was the type of data center. And it was able to provide 100% renewable energy, almost 100% renewable energy through its operations as well. So that was quite key for that data center customer. Due to Niagara, the customer also managed to improve their PUE rating from 1.67 to 1.05. So again, Niagara, with the added benefit of the ILC control hardware, was able to meet that and bring their PUE rating down. Phoenix Contact, again, because we are a manufacturer of industrial solutions, so we furthermore supported this customer and provided UPS solutions to offer for power reliability within their data center as well. The IRC controller is a bus coupler as well, so there's offers a solution in terms of the same IO design modules. So I don't know if you saw there on the previous slide, but the remote IO, so Modbus TCP or Modbus RTU, the same type of modules can be used when you're using the modules for the ILC controller. So what that does for the customer and in terms of design is it basically massively reduces stock complications, so that, you know, if you needed a digital input module, you don't need to think, oh, am I connected to a bus coupler? Because if I am, then I need this type of module. If I'm not, then I need that type of module. The module is the same, whether if it's going to be connected directly to the building controller or via a remote bus coupler, for example. So again, that reduces downtime, that reduces your stock holding, for example, and it also reduces cost as well for the customer. So just a brief summary. So Phoenix Contact offer more than 60,000 products for the data center market. So we have a wide range of solutions, which I've got a screen, a picture there on the right hand side. Niagara is a popular software that's used obviously for building automation applications, but equally it's also growing its importance in data centers as well. And the ILC controller basically allows you to engage in light and heavy commercial requirements. So one of the key topics of my presentation was scalability. So hopefully you saw from the previous slides that the ILC offers a remote solution, but also scalable. So you can have one IO module connected, but you can have as many as up to 63. So in terms of its scalability, it's very flexible and unique. The robust hardware and the embedded Niagara software is what complements both and meets, I think, what the data center market is looking for: a modular type of design, smaller, compact in footprint, and easier, quick in commissioning for the M&E contractors or the OEMs, for example. Because it's a building automation system hardware, again, as I mentioned earlier, because it's a industrial grade hardware, and what we've done is kind of moved it over to the building market. We've seen that a lot of what customers are now looking for is that industrial PLC look and feel in the market, but actually with the added benefit of, say, let's say, for example, Niagara in this instance. There's a seamless integration with the building requirements, and obviously with the centralized IO. And data centers are becoming more modular, as I said earlier as well, in its design. So the actual hardware and software complements this with the data center operators. And yeah, that's pretty much me. I don't know if there's any questions.
Thank you so much, Deepan. Just briefly, you brought us almost up to when we're going to let everyone free to go get a cup of tea. But just in general, what do you think kind of building automation is going to look like over the next kind of 10 years in terms of data centers and things becoming more automated in general, so we can hit sustainability and efficiency, goals that we want to meet?
Yeah, I think the actual importance of controls is going to grow as the demand on our data centers is going to grow with building controllers in specific, because hopefully from the PowerPoint you saw that what we are looking to do in the market is the importance of renewables and how that plays a part in its data centers, and being able to look at efficiency in terms of energy and its footprint. So I think building controls is going to be ever more growing requirement for data center operators to look at ways to improve. And just from the presentations that we've seen this morning, is talking about the key topics: sustainability and system availability. So sustainability is talking in terms of how efficient can we be, how can we lower our carbon footprint with these data centers. So it's looking at things like the solar farms, it's looking at things like earlier was talking about the district heating as well. So the energy and the heat that gets created from data centers, rather than just kind of circulating that and trying to wasting that, we can use that. And equally, I think it is important that we work more collaboratively with local governments to improve that, so that obviously the data centers that can reuse that heating. And that's just building controls will play a huge part with that as well, I think, because then equally it's making sure that maintenance is also quite crucial for that as well. So
yeah, once again, going into that idea of working collaboratively and not in silos, which is the only way we're going to really achieve anything. Okay, thank you so much for joining us today. We've sort of come to the end of the session. So thanks again for presenting today, and have a great day, rest of your day.
Thank you very much.